Okay, hello and welcome to Primitive. I think that's what I'm gonna call this channel. I'm mad. Not mad, by the way. Yeah. So, this is the first video. It's my first time. Please go easy on me. Yeah. This channel is going to be dedicated to programming. Actually, I think I'm gonna focus on C++ as the main programming language. Just so you know, I'm not a pro at this thing. I just know the basics to a little advanced stuff, but I'm not a pro. But I'm comfortable enough with my basics. So the focus on the video, on today's video, is going to be on these three things. Well, it's actually more than three, but I'm going to write my first Hello World program and thoroughly explain what does what in the program so that you can know the next time you write a program why you have to write something, why you have to go through it, so and so, why so and so and so is needed, those kind of things. And I'll jump into variables, the basics of variables, strings, integers, and floating point numbers, and operators. I think I made a mistake here on operators. I'm only going to focus on two things: assignment operators and arithmetic operators for now on today's video, because if we are to go to like comparison operators, I would have to get into like the whole control flows and whatnot, which is a little bit further than what we are here for. Today is just the basic. I want you to understand, like I really want you to understand the Hello World program and how to modify it a bit to give you what you want from it, possibly. And I'm not going to dive into logical operators too, because we're not there yet. So what we're going to do here is the first Hello World program thoroughly explained, and basic variables, strings, integers, and floats, and operators on assignment operators and arithmetic operators. And this is how I read this. Okay. Yeah, I read this. This is your study guide. I read this, so I'm only going to focus on this section here for today, possibly till Tuesday. Yeah, I'm only going to focus on these things. Your first program, integers, variables. I don't know why they wrote it this way, but yeah, integers, variables, assignment operators, assignment statements, assignment operators, kind of the same thing. So, and variable diagrams. I'm not gonna do this because I don't really think it's going to be that important to you for now. I said I'm going to focus on floating point numbers and strings and character variables. So let's dive into it. Here we are. This computer is slow, but anyway, here we are. I'm going to remove all of this. I was just showing someone something. So here we are. I'm gonna do this comment. I'm writing my first Hello World program. I'm going to explain what everything does. I'm just typing for now. I'm just so that you can get a clear picture of what I'm doing, but I'm going to explain thoroughly what each and every line does. Line, multi-line, comment. It can, span up to this for and this for. And I know where you're staying from, where you are right now. Your manual does not tell you, does not really explicitly go into this. They don't do this. They just start with include IO stream. iostream. They just start with that, and then they use using namespace std. Wow, we're about to get sick. Anyway, yeah, using namespace std, and then they just jump on your manual. They just jump to like integer main, which is the main function for the whole program. Integer main, and then they just write count. Hello world, and they say return 0. I mean, this is how basically the hello world program is structured. The basic, like each and every programming language, they start you with the hello world program. It's kind of different. Well, it's actually more different for like different programming languages, but this is how the C++ works. It starts this way. I'm going to explain thoroughly what each and everything here does, but for now, let's compile and see if there are no mistakes in my program. Compiling 3 seconds, that's a lot. As you can see, there's 0 errors, there's 0 warnings, which means it compiled successfully, and there are no errors in my code. And then let me run this. There it runs. As you can see, the hello world, it's outputting hello world. This is the first program that you are going to write as a programmer, almost on each and every programming paradigm or language, if I must say. Should stop using big words. But yeah, this is our first hello world program. And to start with, let me explain to you what everything here does. So as you can see, I started writing this as a comment. You might be wondering why, if this is the first time for you, you might be wondering why this is the first comment and whatnot. In programming, we have what we call comments. Comments are lines of code, not lines of code, but statements that we write inside our code, inside our programs, so that we can remind ourselves what does what, when does what. If right now I want to remember the date I wrote this program, I can just write it here and say, I don't know, it's the 1st or 2nd of April 2023. This is the date I'm recording this. I don't really know what's the date today, but yeah, I can just write that. The compiler is going to ignore everything that comes after these 2 forward slashes. So for me to write a comment, I can't just write this. It's going to produce an error. If I compile having written this, or having written, let me say, count here, count, God, hello world. Oh yeah. If I do this and say compile this, it's not going to compile. It gives me an error. As you can see, it's already highlighting that there's an error that it cannot. So you cannot write code here. It wouldn't make sense. Each and every bit of code, the logic of the code that you are going to write is going to be inside this, between this curly brace and this one, the ones that are highlighted in pink. It's going to be in there most of the time. There's a way of writing it somewhere here, maybe, possibly even there, but for now we're not going to do that. Let's respect what we're being taught. So if I want to write another comment and say, let me say this was written by Matt. I want to tell whoever is going to read this code that it was written by me. I cannot just write a comment like that and say compile. It's not going to work. It's going to give me an error there. Wow. Okay. I think I just broke this, but I don't think this is gonna work. Where are you? Okay, let me do this, because that was no. No, there, it stopped. Let me open this again. Yeah, I almost broke my computer. Wow, this is intense. But yeah, as I was saying, you cannot just write comments like that. As you can see, in fact, it's a good thing that happened so that you guys can see what kind of things, sort of things would happen if you did things like that in your compiler. So you have to be careful of what you write, basically everything. So I cannot write a comment like this. This is wrong. I have to put 2 forward slashes and say this was written by Matt. And then if I compile like this, there, compiles. Very quick, done, compiles. So each and everything that you want to put in your code, like who wrote this, or if you want to explain what a piece of line of code does, you can write a comment. I can even write a comment here after this and say for 2 forward slashes and say this is a way to output data, so that whoever is going to read this knows that this line of code outputs the data that is inside these 2 calibraces. Not calibraces, those I don't even know what to call them. Can't believe I'm a programmer and I think like this. Anyway, yes. So that's what comments does. If you want, you can write a multi-line comment like this one. If you write a forward slash and asterisk, and then you write another asterisk and a forward slash, and between them, let me do this so that you truly understand. If I write something like this, between these 2 things, I can write whatever comment I want. Even if I skip a line and write on the next one, it's still going to be a comment. Anything between those 2 things is going to be a comment. The compiler is going to ignore that. As you can see, as I'm running, I'm compiling. It says 0 errors, 0 warnings, which means everything that I wrote is okay because I commented my code. Everything that the compiler doesn't have to read, I'm just going to comment it out. Okay. Let's leave this. God. I'm sorry, I'm using a laptop and this keyboard is too small for me. That's why there's so many grammar errors in this. Okay, let's leave comments. And now they include IO stream. So this is everybody's going to watch this knows English. So when we say include IO stream, we're just telling the compiler to include the library, the C++ library called IOStream. The job of IOStream, here I'm using my comments to explain to you what does what. So I'm going to use a comment to explain what this line of code does. This allows us to work with output and input. So this is the library that allows us to work with input and output. If you want the user, someone who's going to use your program, whatever code you are going to write, to be able to input data and output data into the console. I'm not going to explain what a console is, but as time goes on, you'll know. You have to include this library. This is the library that allows us to work with that kind of, that allows us to do those kind of things, make output and take input. For example, if I'm to, let me say, comment this out and tell the compiler not to include that library, I'm commenting it out, which means the compiler is going to skip from that part. And I say compile, I run compile. As you can see, it's already giving me an error. Cannot output. Line 12 is the count. I'm going to explain that in a few minutes, but it's already giving me an error, which means I have to include. All the time when you're working with output and input, you have to include the IOStream library. Let me comment it out, uncomment it, and then say compile again. There, my program runs and there's no errors. I can even run it. There it runs. No errors, no nothing. Fine, smooth. And then using namespace standard, which means here we are telling the compiler that we are going to use the standard library for the program. We're going to use the standard library. I'm not going to dive into this too much because it's not really important at this point, but for you to understand, just the basics of it is just we're telling the compiler that we are going to use the standard C++ library in our program. You'll see maybe next week as I explain further what does what on some point, why we have to include the standard library. But this allows us to use this C++ standard library. I'm just gonna leave that there. And now the integer main. This word stands for integer. Everywhere you're going to see it, it stands for integer. I'm not going to dive into that too much, but what you have to know, I've already showed you this program. I'm going to cancel this out and explain bit by bit. Each and every C++ program has this function. This is a function. This whole thing is a function. The integer main. The main. The reason it's called main is because it's the main function. As soon as you run a C++ program, it's going to run this main function. Automatically, it's going to run that. I told you I'm not a pro. I cannot explain further as to what, but what you have to know for now, we'll dive into other things as time goes, is that each and everything you are going to write has to be between these two brackets, curly braces, this one and this one, which means it's inside this main function. I don't know if that makes sense. Please ask questions in the comments below, but that's what it's the main function. It's going to be run by, how do I say this? Your main program, like, I don't know how to explain that further, I'm sorry, but yes, each and every bit of code you are going to write for this practice is going to be inside the main function. So let me say I do what they did on your textbook or your study guide. I say count hello. Why do I keep doing this? World. I say return. Return O. There it is. Every bit of code that I'm going to write has to be in here. Before I explain further, let me show you. This is the count keyword. This word is the word that allows us to output data into the console, like each and everything that we want to write. In this case, we want to see like the program output hello world. So wait. This is the way to output data into the console. This actually, as it's written out, it means C out, console out. The C stands for console and the out is for out, actually out. So it's a way to output data into the console. And when you say compile, then we run the code. There, it's outputting the data that we want to output, hello world. Let me say, for example, you want to output my name is Matt, and we say compile. There it compiles our code, and then we run the code. There it's outputting my name is Matt. Everything that you want to output is going to output. Everything that you are going to put between these two words, there's going to be an output of that, simply because we are telling the console to output this thing that we wrote in here. Whatever it is that we write in here is going to be output into console. So our way to output data into the console is the cout, console out. I think I'm taking too long on this video, but I'm trying to explain as thoroughly as I possibly can. And then the return statement. For now, let's just say this is for now. I'm going to explain further as we go forward, but for now, let me say you just have to have a return statement at the end of each and every function. As I told you, this is the main function. This function is the main function, and we want it to return data. What kind of data? We are returning a 0. The reason I'm not going to dive into what return does is actually it just returns data from a function, but I'm not going to dive into that because I don't really like you're not gonna need that for now. As we go further, you'll know. So this is the return statement. Let me show you what the return statement does. As you can see, I said return 0 here. Let me say, for example, I say return 100, and then I say compile. There it compiled without errors. Here's what it does. As you can see, the count, the C out, it outputs my name is Matt. There we have my name is Matt. And then the return statement, what it does, as you can see, process exited after so and so seconds with the return value of 100, which means the return statement, it just returns the value like an integer. It has to be an integer since the main function is an integer here. So each and every number here has to be an integer. But I would recommend that you always use 0, because as we go forward, you're going to like dive into the main reason why there has to be a return statement. If I do this, for example, I comment this out and the compiler is not going to read that, and I say compile. There it compiled, and then I run the program. There, my name is Matt, process exited after so and so seconds, and the return value is 0. Still says 0. You see, like, it's important, but at this point it's not important that much because we don't really need a return value. We're not going to use it for now. But I would recommend that you always include it in your main function, just to be safe, because as they mark you for, I don't know how they're going to mark, but yeah. Okay, now that we are done, I'm done explaining to you what this is, the main, like the hello world program, what does what. I'm going to switch again to, let me remove this. Okay, I'm done with this. Basic variables. So in programming we have variables. To explain to you what a variable is, we're here, people, to explain to you what a variable is. Imagine that, let me remove this for now. Okay, my return statement, I'm not gonna remove that, I'm just gonna leave it there. So imagine you are writing a program and you want the program to store some form of data, like you want, let me say, you want it to store a name and a surname, let me say a name and a surname of someone and age. So variables are containers, sort of like containers that store information. A variable can be an integer, it can be let me switch up quick. It can be a string. A string is a string, like when we talk about a string, we're talking about alphanumeric characters. Like a name, when you say Matt, it's a string. To the program, it has to be a string. When you talk about integers, we're talking about numbers without, like, non-fractional numbers, like 1, 2, 3, and so on. Without 2 point something, without 2 point something, or 3 point something, just 1, 2, 3. Those numbers, those are integers. And when we are talking about floating point numbers, we're talking about those kind of numbers, fractional numbers, like 1 point something, 1.3 something, those kind of things. There are more variables, types of variables, but I'm going to focus on these ones mainly because they are the ones that we use mostly. So for example, in my program, let me say I want to store a name. Let me say my name. So I'm going to tell the program that string name equals to, I think I'm getting too far, but I'll explain everything to you. Matt, and I say int. I think I'm gonna have an error here, but let me go ahead and continue. Surname, O'Brien. That's not my surname, by the way, but I'm just gonna use that. And I say age into int age equals to 22. Let me run this program and see if there are no errors before I continue, because I'm seeing something. Yeah, I thought so. I don't know why I keep doing this. I think I miss Java. or some other programming language, but yeah, there it goes, compiled without errors. But let's go ahead. These are my containers. Okay, yeah, these are my containers. Let me say count, and I say name, and I put my semicolons there. So I'm using these containers. Okay, let me say float height equals to 160, 70, yeah, 70, height 170.74, 43, I mean. Yeah, there we are. So to store information, like I said, variables are like containers. This is a variable. This part here is a variable. My variable is called name. So if I want to know like the information that is stored inside the name variable, I'm just gonna count name. And let me run before I explain everything further. They're compiled successfully. Let me run this. As you can see, the output is written mad. But if you don't know, like if you are new to this, you might be wondering why is it not outputting this thing like it used on the hello world. Instead of outputting writing name, it's writing mad. That's because I think I'm gonna have to dive into like operators for now. But there's a variable called name. I'm calling it name. And the variable, the value, as I said to you, variables are containers. The value inside the variable name is called it's met. If I change here and say, I don't know, gray. Wow, okay. Yeah. If I say gray and I run this program and I say compile and run it. See, it says gray. It no longer says met. But I didn't change here. I didn't change the variable name. I just changed the assignment. So like here's what's happening. Like I said, this is a variable, a container. This is my container. I am telling the computer right now that I want to store this name, gray. Let me say met again, into a variable called name. That's what I'm telling the computer. This equal sign here is telling the computer that I want to store what is on the right hand side into what is on the left hand side. So whatever is on the right hand side is going to be stored in the left hand side. But that's not enough. As you can see, I wrote string here. So C++ is a very strict programming language. And for me to be able to store names, surnames, sentences, if I say, let me say, this, God, is a sentence. This is a sentence. I want to store a name, a sentence, or whatsoever into a variable. I have to call that variable and give it a type of variable. The type of variable here is string. It's a string type of variable. The variable is name. The name of the variable is name. And the type of variable is a string, which means this is a string. And every time you store a string inside a variable, you have to have this. It has to be concatenated, not concatenated, but it has to be enclosed within these tags, these two tags. This one. If I remove this right now and say this is a string. Okay, let me remove this because it might produce something. Let me say mat. String name is equals to mat. And I say compile. It's not going to work. It's already giving me an error. The computer does not know what this thing is. It doesn't know. But if I put it between these two signs and say mat and I say compile, so the computer takes whatever it is that is between these two things, these two, whatever, and puts them in a variable called name. It assigns them to there. It puts them in there since the variable is a container. And then if I say this is a string and I run compile for argument's sake, there it runs, no errors, no nothing. And if I say run the program, there it output, this is a string. So as I was explaining to you, what I'm doing here is simply storing what is in here into this variable here. And the variable, the type of variable is a string. Same here with the surname. The type of variable is a string, but the variable here is surname. So if I change here name and say I want to output surname instead of name, so name, and say compile, and I run my program, it says O'Brien, which means it's outputting my surname, Matt O'Brien, whatever. Yeah. So as you can see, every time you want to store a sentence, a name, or anything that includes like words and whatnot, you store it in a string. The type of variable, it can be any name you want here, but there are naming conventions to these things. You'll know them as time goes. You don't just write, there are preserved words which we are not supposed to use as variable names. But for now, I'm not going to talk about that. I'm just going to focus on explaining to you what variables are and how they work. Another variable that we have here, let me do this for argument's sake. Before somebody complains, this is a string variable. This is a string variable. And then here, let me comment it out. This is an integer variable. The difference between this age and name is because this is a string variable and this one is an integer. So for integers, as you can see, unlike here, we put this signs, like we put the data that we want to store between the signs. For integers, we don't do that. The computer knows numbers. Well, it doesn't, but it does. So if we want to say integer, any integer, it can be age, it can be year, it can be anything. But we don't have to write it between any. You don't have to do this. It's not like, it's a bad idea. Trust me, it's a bad idea. You just write it that way. So I say age 22. And if I say I want to output the age of this person, whom I wrote the details of, and I say age, I want the age of this person, and I say compile, and I run the program. There it does. It wrote age is 22, even though it didn't write age is 22, but it output the data that is stored in this variable, the variable age, stored 22, as you can see that. But for argument's sake, what? Okay, I couldn't see this. Yeah, 22. So if I write 22, let me say, as I said to you, the integer only stores integers, not floating point, not fractions, not anything, just integers. If I say, for example, 2.5 on this thing, and I say compile, I've never done this, but it compiled without errors. And if I say run this thing, see the problem here. I wrote 2.5 here, but the output here is just 2. That's because this kind of variable, this integer type of variable, can only store integers. As you can see, its age, the age variable can only store integers. So each and every number that has point something, it's just going to take the integer. It's going to round it off into an integer and take that. It's not going to output 0 point something. So if you are going to work with complicated numbers that has 0 point something or 1 point something, we jump into this. Okay, this is God. This is a floating point number. So if you want to work with, let me do this, 22, leave it there. You want to work with fractions, numbers that include point something and whatnot. We use the floating point numbers. If I say I want to output the height right now, height, there I put output in my height, and I say compile and run. There it compiled without errors, and I run my program. As you can see, it managed to output 170.43. which is the exact number that is stored in the floating point, in this variable, the floating variable, the float type variable. I don't know which way to put it, but so if you want to work with complex numbers that includes fractions, 1 point something, in your mathematics, the pi and whatnot, we use floating point numbers. If you want to work with strict numbers, very strict numbers, we use integers. To store strings, names, everything, basically strings, we use strings. And you might be wondering, why is my ID highlighting float with this color and integer in this color and string with this color? There's a reason for that. There has to be a library that I have to include here for me, for this thing to start doing that, but we're not going to dive into that. But that's how variables work. These are variables. These are your variables here. String, integer, and floating point numbers. There are other types of variables like Boolean, but I'm not gonna. But don't focus on this too much. But basically, what this does is, let me say state, or yeah, let me say state. Boolean state equals to true. Why is this thing exactly true? So this type of variable, it can only store only two things, either true or false. And from where you're standing right now, you're wondering, why the hell on earth would I need to store something as useless as that? Well, as you program, as you go further, you're going to realize that this is more useful than the rest of the variables that we used up to so far. But we're not going to use this for now. We're not going to focus on it. And in case you're wondering, if I compile this and run it, it's going to run. There's nothing peculiar that's going to happen. But there are those type of variables and some others. I'm not going to dive into that. So since we're done with variables, I'm going to erase this. I don't know, if you want to copy it, I'm going to give you like 5 seconds. You can pause this video and copy this thing the way it is and save it somewhere for yourself. And we're done with variables. So let me skip to, what is that? Okay, basic variables. We're done with this part. We're done with this. Operators. Wow, this was hard. So I'm only going to focus on assignment and arithmetic operators. I'm not gonna use logical and comparison operators for now. For some reason, I'm just gonna use assignment because I want to keep this video short, because I think I've already outspoken myself right now. So very quick, arithmetic and assignment. Let me start with assignment operators, which are the easiest. Assignment, the word assignment basically means to assign something into something. Like if you have like a piece of work, like let me say you have a yard that's not clean, and you want someone to clean your yard, you are assigning that person into the yard, like to do the work. So, or you want to give someone, a newborn baby, a name, you are assigning a name to that baby. Oh, his name is Clark or whatever. You are assigning the name. This is how this works. We've already done this without you having noticed. Let me remove this and be left with the first one only. Name. So we can have this like this string name and leave it the way it is without putting like anything. And if I say compile, there it runs without no errors, no nothing. There's no output, no nothing. Okay, let me leave that. But for assignment operators, we already have a variable which is name. But I want to put something into this variable. I don't want it to be empty, because if not, right now I say count name, and then I say, and I run this. No. And I compile, because we have to compile before we run everything. It compiled without errors, and I run this. As you can see, it's empty. It's not outputting anything. That's because the variable name has nothing. It doesn't have value. There's nothing inside. It's just a container without nothing. without anything. That is why it's outputting nothing. But if I want to put data inside this variable, I use the equal sign. This equal sign it's an assignment operator, the very basic assignment operator. As I said, I'm going to keep things basic, but it's an assignment operator, which means everything that I'm going to put after this equal sign, let me say my name is Matt. Right now, I'm telling the computer to use this sign to assign whatever, to put this statement inside the variable name. So if I run this, for example, compile, then run, and then run, there it's outputting my name is Matt. You've seen this before, but now you understand how it happens. At least you understand that. So this is not the only way to assign information to a variable. As I've declaring a variable. God, no. Declaring a variable. I have declared a variable, but it has no value. It's empty for now because I haven't assigned anything into it. At a later stage, I can just say name equals to name equals to Mac. Now I have assigned a value into the variable name. This was a declaration. This part I am declaring a variable. I am telling the computer that I have a variable which the name of the variable is name, and the type of variable that it is a string variable, but it's empty. And later I come back and say the variable that is called name, I want to store information inside of it. This is the sign that I use to store information, an assignment operator. And I am assigning this word inside this variable that is called name. And then I am inputting this information to the console. Here I am compiling. And then I run my program. There, Mac. So if at a later stage, and again, I come back and I say name, again, I'm assigning new information inside of it, inside the name variable. It's a container, it can store anything. I say name equals to Matt O'Brien. God. It might confuse you. You might wonder, why do I do this? And you might be wondering, if I run this program, is it going to output this information? Or is it going to output this one? Either this one or this one. But let's see how that works. I'm going to explain afterwards. They compiled, no errors, no nothing. Even though I called this thing twice. And there, name, Matt O'Brien. Instead of outputting the Mac, the variable name is no longer, this variable is no longer outputting this name. It's outputting this one. This is due to the reason that the fact that computer reads code in instructions in like chronological order. Okay, not chronological, but procedural manner. So it starts from the top and keeps reading downwards. So here I declared, I named, I gave the variable name information called Mac. But at a later stage, I turn around and say, nah, I'm not gonna say it's Mac again. I'm gonna store another information inside the same variable. So I tell the computer, okay, this is no longer Mac, it's going to be Matt O'Brien. So the computer takes the last one because the last assignment, the last data that was put inside this variable is this one. So it takes this one and outputs it. There's a way you can be able to output both of them. I don't remember very well but we'll dive into that. But there's a way of doing that. But for now, you just have to know the computer is going to read this in sequence and it's going to take this last assignment instead of this one. Even though this one came first, but it's going to take this one. There's a reason why it's allowed to do that. Because at some point, you're going to change the value inside a variable from time to time inside very big programs. But for now, that's it. Okay, let's leave this. That's how I was explaining to you how operators work. And we are done with assignment operators. And now arithmetic operators. What arithmetic means, it basically means mathematical operators. It might, I know, like programming, I don't know why they use these big words for, but arithmetic operators are used for mathematical procedures. For example, let's come here. Let me remove this again. As I said, everything that we are going to practice with is going to be inside the main function. As you can see, everything that I'm doing is always inside the main function. There are ways as you advance where you're going to write your functions outside. You guys don't know what are functions as of yet, but there's a way you can write a function here. But I'm not going to dive into that. For now, let me say we have an integer. Integer, remember I said an integer is a number for you. Let me say we have an integer. First, I'm going to name, the name of the integer is first. And then we have another integer. Okay, let me do this way to make it simple. And into this first, the integer named first, the integer is a variable. Inside the variable first, I'm going to put, let me say 100, since it's an integer. Remember I said we don't have to put it inside those codes. We do not have to put it inside codes. So the variable name is first, and the variable type is integer. So we have an integer first, and we say count. We are always going to use this, so I don't know why I always erase it. Let me say first, and let's see, there it compiles, no errors, no nothing, and then it runs. There it's outputting our 100, our number 100, no errors, no nothing. So let me say we have another integer. Let me say second, and inside the second variable, integer or variable, you'll forgive me, I'm gonna use the integer most of the time instead of variable. But inside the variable second, which is the type of variable that is an integer, it's an integer type of variable, I'm going to put, let me say 120. Now we have two integers. So I've already told you what this does. It's an assignment operator. It takes what's on the right hand side and stores it in what's in the left hand side. So let me say I have another integer. I call this integer an answer. And I put nothing inside my integer. Okay, fine. Let me say, for example, in fact, I put something. Let me be quick. And I say the integer, the variable answer is going to be equal to, I'm going to put what's on the right hand side into the answer. The answer is going to be, I've already used the logical operator, not the logical, the assignment operator, which is this one, the equal sign. And I'm going to use arithmetic operators to show you how to do math and whatnot. You've already done this, it's basic mathematics. Then I say first plus second, and I leave it like that. So what I'm basically doing, this is an arithmetic operator. So what I'm basically doing, I'm telling the computer that I want to add this number, the first one, to the second one. So I am adding the first number with the second number using an arithmetic operator, which is the plus sign, which means I'm adding. It's basically addition. And I say the count to the count. Please don't mind what I'm doing here right now. The answer is, I'm going to use this because answer. Don't pay attention to using this thing two times. You'll see what it does basically. Okay, let me compile this. Please do not be puzzled by me writing count two times. It can be written as many times as you want. There's no limit. Well, at least I think so. But there's no limit from my point of view. So the answer is addition of these two numbers. Here we said this number, the first one, which is 100, add the second number, which is 120. And then the answer that we are getting, the answer is 122. Yes, this is how it works. 100 plus 120 is 122. So this is how arithmetic operators work. You can use the plus for addition, you can use division, you can use subtraction, you can even use the modulus, but I'm not going to talk about the modulus one because it's a little more confusing. But for now, I'm going to focus on the addition, multiplication, division, and subtraction. So there we are. The answer is 120. And if, let me say, I change the number here and say, let me say 30. And then I compile my program again. I compile my program again. And as you can see, right now I'm adding 100 to 30, which is supposed to give us 130. And there we are. Yeah, the answer is 130. We're getting 130. So what this basically does, this variable, the answer variable, it takes these two variables, the first one and the second one, and it adds them together. And the answer that it gets from this addition, it stores it inside the container, the variable answer. And then here, if I want what is stored inside this container, I just call the variable answer because it already has the information of the addition of the first one and the second one. If you want to subtract, it's just easy. Subtraction, it's an arithmetic operator of subtraction. If I say the first one is 100 minus 30, 100 minus 30, it's going to give us, I don't know, 70. I'm using that and I say run. Yeah, the answer is 70, as you can see there. We have our answer is 70. And if I say divide, to divide between the two numbers, we use a forward slash. This is an operator that is used to divide. If I say double forward slash, it's a comment, but if I use one, it's a divider operator. So please don't make the mistakes of doing this and running your program and you get errors. But this is how we divide, apparently, because there's no division sign on the keyboard. So that's why. There, the answer is 3. And if you really put it on your calculator, 100 divided by 3 by 30, it's going to be 3 point something. But problem is, remember when I talked about integers and floating point numbers, it's getting 3 point something. The answer here is actually 3 point something, but because the variable, the answer variable is an integer, it cannot output that kind of information. So if I want the exact number, I'm going to say change the variable type to float. And if I run this as a float, it's going to give us an exact number that we want. And then let's run it. Wait, no. Okay, I think okay, I'm not gonna dive into that. I see what's happening, but I'm not gonna dive into it. But if you really want numbers that are, what do you call this? Oh God, you know what? Beginner's luck. There, 3.33 something, yeah. But I didn't want to do that. I don't like the idea. But yeah, there we are adding a floating point number, but I like using integers because I want you guys to understand to a full extent. Yeah, we can store the answer in a floating point number, then we'll get the output that we are looking for. I think I've taken too long, and that's it, people, for now. See you again next time. This video is too long, I'm sorry. I think I've covered pretty much everything here. Let me see. Your first program, I've covered that: integers, variables, assignment operators. Variable diagram, I told you I'm going to skip this because I don't see the input. Well, I actually talked about it where I showed you how the program, like the computer, reads your code in what sequence. And floating point numbers, I've already showed you this. And strings and character variables, I've showed you this. I think we are done for the day. Have a good day, people. I'm sorry for taking too much of your time. Thank you.